Good afternoon. Today we are continuing on with our Unit 5. We are working on CO31. I can determine if two ratios form a proportion. So we're still working with those ratios. Today we're talking about proportions. So our first thing is, well, what is a proportion? A proportion is equivalent fractions, ratios, and rates. So we've worked with fractions. We've done equivalent fractions before, right? Can I multiply or divide down to the same thing? Equivalent fractions. Whatever I do to the top, I do to the bottom. You're using that same scale factor. Ratios. We talked about ratios a couple objectives ago. Last objective is the unit rate, right? We do the equivalency the same way we do with our fractions. Whatever you do to one side, you do to the other. Multiplying up, dividing down. So we already know the concept of being equivalent. Now we're just applying it to our ratios and rates. So each of the following is a proportion. We're going to look at 5 different ways that we can prove they're a proportion. And when we're doing our work, we're going to decide which way we're going to use to prove it. Because some ways will work for certain things and some ways won't work. So you have to know which one we're going to use each time. So the first way is using the scale factor with multiplication. I've used this term a lot. Who knows? What is the scale factor? Henry? 3? I'm looking more for a definition. When we say scale factor, what's a scale factor, Henry?
Like what the smaller number has to be multiplied to equal the other number.
What number you're multiplying both the top and the bottom by. That is the scale factor. So Henry said, oh, well, the scale factor here is 3. Because 4 times 3 is 12, 3 times 3 is 9. So our scale factor is that 3. Right? It's what you're multiplying the top and the bottom by. That's what we've used to find those equivalent fractions. We've been using this. This isn't a new one. The second one is doing scale factor. But this time with division. When we are simplifying down. So same idea. Instead of what am I multiplying by to get up to the next fraction, now it's what am I dividing by to simplify it down. So what would our scale factor be here? It's still that 3, but this time we're dividing backwards. So we're dividing that bigger fraction by 3 to simplify it down to 3/4. So we can multiply up or divide backwards. Sometimes we start with the bigger fraction and we simplify it down. Same concept, right? We've worked with fractions like this before. This is the new part. So let's look at 3 more ways to look at those proportions. This one, again, not a new way. We can use simplifying. If I look at 3/6 to 4/8, I don't know what I'm multiplying up by. I don't know what I multiply 6 by to get to 8. But I can simplify them both down. I know 3/6 can get smaller. I know 4/8 can get smaller. I can divide 3/6 by that scale factor of 3, and I would get 1/2. I can divide 4/8 by a scale factor of 4, and I get 1/2. it simplifies down to the same fraction, it's a proportion. Right, equivalent, multiplying up by the same scale factor, dividing down by the same scale factor, they're proportionate. Because we're multiplying and dividing by the same scale factor. Simplifying down, if I can simplify down to the same fraction, it's a proportion. Okay. Now, the bottom two are our new ones. Okay, we know how to multiply up, how to divide down, how to simplify. That wasn't me. These two are new ones. We look at 15 over 25 to 114 over 190. Oh my goodness. That looks kind of confusing. I have no idea if that's a proportion. So, one way we can figure it out is by using cross products. Doing cross products, we're making a cross. And the math that we're going to do is we're going to multiply. So when I make that x, I'm multiplying these two, so 15 times 190, and I'm going to multiply these two, so it's 25 times 114. Get out your calculators and tell me what those equal. What is 15 times 190, Madeline?
2,850.
2,850. What is 25 times 114? Elliot? 2,850. They are the same. So they are a proportion, because my cross products are the same. If I look at this one right up above, I could use cross products. What's 3 times 8? Just say it.
24.
What is 6 times 4?
24.
So I could simplify it out. I could also do cross products, right? As long as they equal the same number. So these two numbers times these two, and those two numbers, when you multiply them, they equal the same thing. So your cross products are the same. Make sense? All right, our last one is decimal values. What operation does our fraction bar mean? Madeline? Division, right? When we have that fraction bar, it means divide. What is 8 divided by 7? Use your calculator. 8 divided by 7. You have to make sure top number divided by bottom number has to go in that order. Joe?
1.14.
1.14. What is 28 divided by 24.5? 28 divided by 24.5. Use your calculator. What'd you get, Finley?
1.14.
1.14. Look at that, they're the same. So finding those decimal values, if the decimals are the same, it's a proportion. Sometimes we end up with like 3 or 4 different fractions or ratios, and we need to find out if they are proportionate to each other. It's kind of hard to do some of these other ones. You can always do the decimal values. Divide numerator by denominator for each one. If they all equal the same decimal value, they're a proportion. How do we feel about these 5 different ways? Show me your thoughts. Are we feeling more understanding? Okay, so let's look at our work page. In this top section, It says using two of the methods discussed on the front, determine if the values are proportional. Show your work. So we have to make sure we're following all the directions. So I look at 4/5 to 20/25. What's one way I could use to show they're proportional? Clara?
Times them by 5. Like, or
I can do the scale factor with multiplication. 5 times 5 is 25, 4 times 5 is 20. Are they the same? Yes. What's another one? Because I need to do two ways. So I showed one using scale factor with multiplication. What's another way I could use, Holland?
the decimal values.
Decimal values. What's 4 divided by 5? Use calculators. 4 divided by 5. Holland?
0.8.
What is 20 divided by 25? Holland?
0.8.
I'm showing it by using the scale factor with multiplication. I'm showing it with my decimal values. The answer is yes, they are proportionate. I showed it two ways. Could I have used cross products?
Mhm.
Yeah. Could I have used scale factor with division?
Yep.
Yep. Could I have used simplified?
Mhm.
Yeah, I could have simplified 20 over 25. That looks the same as scale factor with division for this one, right? You decide which ways you're gonna show. You need to show two ways. You're gonna write yes or no. If they're the same, it's a yes. If they're different, you write no. But show it two different ways. So I should be able to look and see which ways you're using. Any questions on the top part? Okay, put your pencils down. I know we just want to work. Put our pencils down. That includes you, Colton. Okay, let's look at the trickier part. We get to word problems. A juice recipe requires 5 cups of orange juice for every 2 cups of water. To make the recipe for a group at summer camp, the counselor mixes 45 cups of orange juice with 30 cups of water. Will the juice taste the same as the original recipe? If not, what will be different? So, what do you think we have to do? Ellie, I asked for pencils down. What do you think we need to do to solve this problem? Joe?
Set them up in the bracket.
Yeah, I need to set them up into those fractions, that ratio, and then I have to determine if they're what? Proportionate. So what's my first ratio? Colton?
245. No, wait, 2.
I have 5 cups of orange juice for every 2 cups of water. What's my ratio?
5-2.
So 5 cups of orange juice for 2 cups of water. Notice how I'm labeling them, because where I have orange juice, it needs to match up with the orange juice. So in my next one, I'm gonna put the OJ on the top. So how much orange juice am I using for my second ratio? Elliot?
45.
45 cups. How much water am I using? Finley?
30.
30 cups of water. So my first thing, does it taste the same? Are they proportionate? So we need to determine, are these two ratios proportionate? You can use any of those ways. Are they proportionate? Use a way. Right now, use a way. Determine if they are proportionate or not. You're going to have to tell me which way you used. Bo, tell me which way you used first.
The cross.
Okay, so Bo used the cross products. So he did 45 times 2, and he did 5 times 30. What did you get for 45 times 2?
45 times 2. 9.
And what did you get for 5 times 30?
150.
Not 100. 5 times 30?
Yeah, 150.
150. Oh, that's what I thought you said. Okay, is that a proportion? So is it gonna taste the same?
No.
So our first answer is no, it's not gonna taste the same. Second question, if not, what will be different? Is it gonna be more orangey tasting or more watery? What do you think, Colton?
Watery.
Why?
Maybe 60 cups of water too high.
Because to go from 2 to 30, we multiplied by 15, right? To go from 5 to 45, what are we multiplying by?
9.
So we're adding a lot more water. So it's going to be more watery. Does that make sense how we figured that out? So know what we're working on. We're working on proportions. When they ask a question, you're gonna have to set it up into proportions, into ratios, determine if they're proportionate, determine, like this one, targets those bananas in bunches of 8 for $4.16 or 12 for $5.88. Which one has a better price per banana and by how much? So you have to determine, is it proportionate? Oh, I'm guessing by the wording of the question, it's not gonna be proportionate. So which one is a better deal? Use the information that we've learned in the last 2 objectives in this objective and try to determine, what do you think you might wanna use to solve this one? What would you use, Elliot? So, it's already kind of telling us that it's not a proportion. Because it says, which one is a better deal? If it's proportionate, it's gonna be the same deal. So it doesn't matter which one you buy. So already in the question, we know it's not a proportion. So now think back, I said think back to our other objectives. What do you think we could use to know which one is the better deal, Grayson? Yeah, find the unit rate. Well, if we know $8 bananas is $4.16, how much is 1 banana at that rate? How much is 1 banana if 12 costs $5.88? Bring it down, put the banana on the bottom and bring it down to a unit rate of 1 banana. How much is it gonna cost? Figure out which one's cheaper. Does that make sense? So the word problems aren't as easy as doing the top part of our page, right? We can determine those proportions. We know how to do that. We're getting practice doing the different styles. The word problems, we have to use a little more critical thinking. What is it asking for? How can I solve it using all of the knowledge that I already have? It might not just be from this objective, it might be from previous objectives. You're gonna figure out the last word problem on your own and then do the review. Any questions on today's assignment? Show me your thumbs, how are we feeling? Okay, when you are finished, if you finish before class is done, don't go so fast. Yesterday we had people going too fast and they're like, oh, I divided it by 6 instead of 60, divided it by 4 instead of 14. Make sure you're going slow and you're doing it correctly. We want to get in that habit of checking our work as we're doing it so we don't make those simple math mistakes on the test. Okay? You know what you're doing, you got to be able to show it. So don't rush just to be done. Make sure you know what you're doing and you're doing it correctly. If you get finished before class is done, you're working on packet number 5. Did I go through the formulas yesterday? Okay, so work on that packet 5. If you are watching at home, I hope you are well. I hope to see you soon. Have a wonderful day. And don't forget to like and subscribe.